Okay, so what we have here is a visualization of elliptic curve cryptography, specifically a core component of it called the point addition process. So what is elliptic curve cryptography? So it's intended as a drop-in replacement for modular arithmetic as it's used in common crypto systems like RSA and Diffie-Hellman. And the purpose of the elliptic curve over more conventional modular arithmetic is that the properties of the curve and this point addition operation allow you to have more sort of cryptographic power or entropy per bit of keying material or number of cycles or whatever, while maintaining the nice mathematical structure of modular arithmetic. So, okay, so what are we looking at here in the video? So I'm plotting, you can see the x and y axes, I'm plotting an elliptic curve. You can see the equation of this curve in the top left. It's an implicit function because of this square root, so you have these two leaves of it above and below, but that's okay. So I can change the parameters of this curve, and you see we get a variety of different shapes. And all of these are valid elliptic curves, although as we'll see in a moment, there are considerations with these. So, okay, so these are the different curves, and the operation, as I mentioned before, is something called point addition. So what does that mean? So first of all, we're going to choose a point. So we'll choose that point there as our first point. Now, what point addition does, and it's different for the initial point, but what point addition does is it essentially calculates the tangent line to a curve, and wherever that tangent line hits the curve, which you can sort of imagine this is going to hit down here somewhere, it finds where this point collides with the curve, and then it mirrors it over the x-axis. Okay, so I can do that. So okay, so this is what it did. So this one intersected somewhere, and then we go here. Like I say, it's different for the initial point. So for the initial point, it has to be handled differently because there is no prior point with which to calculate the secant between them. But it can proceed from there. So this is our second point. So what we're going to do now is find the line between these, where it intersects the curve, and then mirror it over the axis. So this is probably going to go, yeah, so this ended up way off screen, but if we do it long enough, it'll come back. So let's, okay, so this is a better example. So this point to this point, if we imagine where that line that passes through them would hit the curve, you can see it would probably land somewhere over here. So I'm betting this is going to be down here somewhere. And you can see that that's what's happened. So I'm not showing the tangent lines, but I am showing where the points go, primarily to visualize that where the point ends up after this point addition operation is highly chaotic. So you can see that while it doesn't tend to blow up to infinity, it also doesn't tend to follow any real pattern either. And I'll let this run for a while so you can see that. Okay. Now, one thing to note, so let's make a new curve. We'll go with this one. So one thing to note is that, okay, it is deterministic, so I know it's a little tough to see, but you can see that it is deterministic. However, okay, so this made a pattern like this, right? If I go just a little bit to the side, you can see we get a totally different pattern. And just a little to the other side, again, we get a very different pattern. So this is a very chaotic system under this point addition operation. Now, there are a variety of curves. So some of the curves have these two separate surfaces. And these are sort of interesting because if I start with a point over here and go like so, you can see that it eventually moves all over the curve. So it hits points on this part, and it also hits points on this part. However, if we start the point over here, you notice that it actually never leaves this part. And I've run this for a very long time, and it's always over on this part. Okay. So, this is elliptic curve cryptography, the core nugget of it, using the point addition operation.